Welcome back to the Basic Electronics series. Today we will learning about diode circuits and power rectifiers. Here is the agenda: diode biasing, rectification, half wave rectification and full wave rectification, power rectifier and numerical problems. So this is diode and this is the symbol of diode. So diode is nothing but it is a semiconductor device that allows current to flow in only one direction, which is also called unidirectional. Diode biasing. So there is two types of biasing. One is forward bias, one more is reverse bias. So it is mainly depending on how it is connected. Diode biasing means applying voltage to diode, so it can work properly in a circuit. So this is forward bias. So here anode is connected to the positive terminal and cathode is connected to negative terminal. So what happens means depletion layer becomes thin. So diode starts conducting and current flow easily. So silicon diode having voltage 0.7 volt and germanium diode 0.3 volt. After this voltage, current increases quickly. So forward bias means diode on and conducting. So this is reverse bias. So here cathode is connected to positive terminal and anode is connected to negative terminal. So depletion layer becomes thick. So current almost stops, only very small leakage current flows. So diode blocks current here. So reverse bias means diode off and there is no conduction. So next is the rectification. So rectification is the process of conversion of AC to DC. It requires power supply, chargers, electronic devices. So diodes perform this process, so it is called rectifiers. See here, this is AC voltage source. So it is the process. It is converted to the DC voltage. So this is the half wave rectification. So half wave rectification here. So during the positive cycle, so this is the positive cycle. So that time diode becomes forward biased and current flows through the load. So output voltage appears. See here, we can see the output voltage. But during the negative half cycle, the diode becomes reverse biased. So there is no current flows and output is 0. So only one half of AC waveform appears here, right? So AC gets converted into pulsating DC. So half wave rectifier has both positive and negative cycles in input, but the circuit is a half wave because only one half cycle passes, right? Here see, only one half cycle passes. So in input we will give both, but in reverse bias condition it gives 0 output. And next is the full wave rectifier. So full wave rectifier is nothing but it will convert AC into DC by using both positive and negative half cycles of AC input. So there is two types: center tapped rectifier circuit and bridge rectifier circuit. In center tapped transformer we have in center tapped rectifier, but in bridge rectifier doesn't require a center tapped transformer. So this is the center tapped rectifier. Here we having the transformer. So during positive half cycle, the upper end of the transformer becomes positive. So this diode conducts and current flows through the load resistor. So here output wave is up here. So output voltage here you can see. But during negative half cycle, lower end becomes positive. So second diode conducts. So current again flows in this direction like this. Same direction through load. So both cycles produce output. That is in positive only. But in case of bridge rectifier, here we are not using transformer. Instead of transformer, we using 4 diodes in the form of bridge. So during positive half cycle, 2 diodes becomes forward biased. So current flows through the load resistor and output voltage appears. But during negative half cycle, again 2 other diodes are there, right? That will conduct. So current still flows in same direction. So both cycle give the output. So here you can see, in positive cycle also you will get output, in negative cycle also you will get output. Why positive means both are moving in same direction, right? That's why same voltage we will get in both cycles. Next is the power rectifier. A power rectifier is an electronic device or circuit. So it converts high AC voltage or current into DC using power diodes or controller diodes. So classification based on degree of control. There is 3 types: uncontrolled rectifier, controlled rectifier, and one more is semi-controlled rectifier. So uncontrolled rectifier, in the name we can say it is not controlled, means it is fixed. So the output voltage is fixed based on the input AC magnitude, so that cannot be adjusted. So these are power diodes to convert AC to DC. But in case of controlled rectifiers, so here we use SCR or Thyristor. So by controlling the trigger pulse to the gate, the average output voltage can be varied. But in semi-controlled rectifiers, so it is a combination of both uncontrolled and controlled. So they are often used to reduce cost while still providing some level of output regulation. Here you can see this is the controlled and this is the uncontrolled rectifier. So this is uncontrolled rectifier. So as soon as AC voltage pushes, in right direction, so this diode opens automatically. So that time you get a fixed amount of DC power. But you cannot change how much voltage goes to the load. So it just gives you everything the AC source has to offer. So here you can't adjust. Here you see we having 6 diodes. But in case of controlled rectifier, so here instead of diode we use as SCR, right? So this is the SCR. So pink symbol labeled T with the extra little gate line sticking out. Here you see, right? So even if the electricity is pushing in the right direction, the SCR stays closed until it receives a trigger or pulse at the gate terminal. So you can wait a few milliseconds before sending the trigger pulse. By waiting longer, you choke off part of the electricity wave, which reduces the average power going to the load. So you can control the speed of a motor or brightness of a light by adjusting exactly when you fire the SCR. So it is controlled rectifier. And next is the based on input supply, we having two types of rectifiers. One is single phase rectifier and one more is the three phase rectifier. So single phase rectifier, so during first half cycle, we know right, AC input how it is there. So during first half cycle, electricity come in from the top wire. Here you have it. So two diodes steer it, so it goes down to the load. So in second half cycle, electricity swaps and come in from the bottom wire. This is during second half cycle. And the other two diodes steer it, so it still goes down to the load in the same direction. So even though the input is swapping back and forth, the output always flows through the load the same way. However, there is a tiny movement. So when the AC is swapping where the power hits zero, which is why you see those big humps in the graph. Here you can see the big humps, right? But here there is no big humps. So in single phase rectifiers there is two inputs, but in three phase we having three input terminal. So in three phase, instead of waiting for one wire to swap directions, the bridge constantly grabs power from whichever two wires have the highest voltage difference at that exact microsecond. So because there are three phases, right? So there is always at least one phase at a high voltage while the others are swapping. So the gaps are filled in before the voltage has a chance to drop it to zero. So this is why the three phase graph looks like a slightly bumpy, straight line rather than the big hills. So in three phase we are using three input terminal. So this three phase is used for heavy industry like factory motors, electric vehicle chargers. So it provides much smoother, more powerful rock steady energy. But this single phase is for home electrons like phone charger, TVs. It is simple but needs big capacitor to smooth out those big voltage drops. So this is about the three phase and single phase rectifiers. Next, based on circuit configuration. This is I already explained half wave rectifier and full wave rectifier, that is one and the same. And these are the numericals which is most frequently asked during the interview. So a single phase bridge rectifier is connected to a 230 volt 50 Hz AC supply with a 1k ohm load resistor, assuming ideal diodes. Now we need to find peak voltage, average DC voltage and peak inverse voltage. So peak voltage is nothing but amplitude or maximum voltage, right? So we having formula of maximum voltage Vm equals to Vrms into square root of 2. So Vm is given, that is 230 volt, substitute, and square root of 2 is nothing but 1.414. So multiply, then you will get this one. So to find the DC voltage, so we having formula 2Vm by pi. So substitute the value of Vm, then pi value we know, right? 3.14. This is the constant value. Substitute and simplify, then you will get this answer. But peak inverse voltage, so that is in bridge configuration, each diode must withstand Vm, right? So PIV means peak inverse voltage is equals to Vm. So Vm is nothing but 325.2 volt. So determine if the diode is conducting in the following scenarios. So anode at plus 5 volt and cathode at plus 2 volt. So this is reverse bias or forward bias. So here anode is greater than cathode, right? So this is forward biased and current flows. Anode at minus 3 volt, cathode at 0 volt. So minus 3 is greater or 0 is greater? Obviously 0 is greater, right? So this is the reverse biased. So there is no current flow. So how to remember this means? So forward bias means the voltage at anode is higher than the voltage at cathode. In reverse bias means the voltage at anode is lower than the voltage at cathode. So that's all about the diode circuit and power rectifiers. For more videos, watch the upcoming classes. Thank you all.